Hey there, I'm John Ferguson Smart, and today I want to show you how you can refactor BDD scenarios to make them more reliable, easier to understand, and more thorough, so that they cover more of your business requirements, more of your features, more of your edge cases, and catch and prevent even more defects. And I'm going to show you how to do that with a real world example that you can see right here. So this scenario is all about resetting a password. So it's a simple enough scenario, but there's enough interesting edge cases and rules that we can get into some interesting conversations about it. Let's read through it just to see what it's about. So if we start at the top, we have given the user is on the application sign up page. And then our scenario, user clicks on the login button, clicks on forget password, enters an inputs an email, and then we've got non-registered email, we'll get a user not found. Registered email, we'll get an email sent. Okay, and then we have the user gets a verification mail in this email via email. So I'm even getting confused reading it. The user verifies the verification code, goes to the password setup and fills some password details, and they go through and do all these password details. And eventually they'll enter a correct one and the password gets set. Now, this is based on a real world user requirement that someone did ask me to review. And what I can say straight away is this scenario has a lot of issues. But the biggest one is that it's doing way too much there, way too much. We're asking way too much of it. A scenario should only test a single business rule or a single user journey. And this one is testing way too much. We're testing at least 3 different business rules that I can identify just looking at it very briefly. We look at what happens when you try and reset a password with a user that doesn't exist. We look at what passwords are valid. We look at also the idea of the verification code. We get an email verification message and verify the password reset with that verification code, and we've got this whole user journey. So really 3 business rules plus a user journey that we're testing. That it's quite a lot. And here we're doing a few interesting things here. At each stage where we've got a table, we're actually doing multiple checks, multiple assertions if you like. That's okay, you can get away with that. I'll show you a few ways you can do that. But here we've got multiple checks here, multiple checks here. It really is very dense and very confusing. So if this scenario fails, who knows why it fails? We don't know what business rule is broken. It's not going to tell us anything. And we're cutting ourselves short because we can't exercise all of the options, all of the variations that might happen in this real world situation for other variations. So let's have a look at how we can refactor this. The first thing I can notice is that, very simply, we're using the word user all over the place. Now, who's a user? User is terribly generic and doesn't really tell us very much about the scenario. I much prefer to use persona names to make the scenarios more relatable. So what I'm going to do here is introduce a persona, say Fabian, the forgetful user. So let's say Fabian is a forgetful user who has forgotten his password. So we're setting the context here, giving a bit of information. Now, this user here, Fabian, he's created an account at some point. We're going to need to know what he actually did with this account. We don't specify any of that here. We just come up with a random user. We don't even say whether the user has been signed on before or is an existing user. It's kind of assumed. Let's make that a little bit more obvious. So we could say something like, given Fabian has created an account with the email address fabian@example.com, for example. Now, we don't have to do that. It would depend. I'm thinking we may use this later on. We may not, but if we do need that email, at least we'll have it there as a reference. The second thing here is we have when the user clicks on the login page. Now, when the user clicks on the login button, That is not strictly relevant for all of this forget password. The going to the login page is a navigation feature which is relevant when you're logging on maybe, but not necessarily when the fact that you have to click on the login button is not relevant for changing the passwords. All we really need to do is say, and Fabian is on the login page. So rather than getting Fabian starting off on their application sign-on page and then clicking on the login button, we'll get rid of all of this. And we'll get rid of this line. So now Fabian starts off, given Fabian has created an account previously with the email and he's on the login page. So we're starting off in the right spot. So that's my first refactoring. I've introduced the idea of a persona and I've got rid of a little bit of the incidental details. Now let's see what we can do next. Right, the next thing we want to do is to refactor this logic here. What we have here in this section is a bunch of business rules all bundled in together. So when I look at this code, what I see is the user inputs an email. First they input one that doesn't exist, and they input the right one, and the user eventually gets a verification message. That is it's a mini user journey. It's a business rule around how we deal with invalid emails or emails for customers who were not registered. And that is its own business rule in its own right. So really we need to define that as its own rule. And we can do that by using the rule keyword. If the email address is not registered, user should be told that the user was not found. I'm sure you could write something more businessy, more eloquent, but that's the general idea. Now, when we have a rule, we usually have an example, at least one example. Example, Fabian enters an invalid email address. So we're splitting out this logic, this step here basically. Now the next step, the user clicks on forgotten password. Never ever use the word click in a BDD scenario, even if it's a UI scenario. Some slight variations if you're doing UI unit style testing where it's very tactical, very local, but generally speaking for business facing scenarios, you never want to use words like click or select which bind you to a particular user interface. So rather than doing that, what we can do is just simply say, given that Fabian has asked to reset his password. And under that, Fabian will probably click on the link. But if the button or the link or the UI changes so he does something else, that doesn't matter. This will stay the same. Now, the interesting thing, we could do this as a table, but it's a positive and a negative scenario, and they tend to be a bit tricky to do as tables. It's often clearer just to have two separate examples. So we can say when Fabian enters, we could specify an email address, or we could just say a non-registered email address. Doesn't matter so much what it is. Won't be very meaningful if we put it there, so we can just say that. Then he should be told user not found is the error. Then we could have another example. What happens if he enters a valid address? Well, that's actually a different rule, isn't it? That's actually a different user journey, because if he enters a valid user address, he actually gets an email sent message because the email gets sent. So we could turn that into its own rule if we wanted to make it really clear. If the email address is known, the user should be sent an email with a verification code. Notice how I'm really spelling out the business rules, spelling out the behavior. If I come back to this later on, I will get a very clear understanding of what's going on, how the application is meant to behave. So we have Fabian. What's he doing? He's entering his email correctly. So, same thing. We're going to start off with, given he's asked to reset his password, when Fabian enters his email address, that would do. Then now we could do a couple of things. We've got this step. He gets an email sent, so he should be sent a verification code to his email address. Now here there is a detail about the message that you display when you send a message. We could have something there, or we could choose not to. That would be up to you. We spelled it wrong. It should be. Anyway, so now we have these two rules. One for when the user, what happens when the user enters address that's not found, what happens when he enters an address that was found. And here in a real situation, you might explore other variations, like what happens if the user address exists, but the user account is expired, or needs, or the payment doesn't work anymore, that he needs to update his credit card, or some other business rule around that. We could add that here. It would be another rule in this part of the requirement, something that we didn't really have in our previous requirement. So that basically covers off this section. So we've replaced that whole block with two rules and an example of each rule. The next line that I want to look at is this innocent looking one here, when user verifies verification code successfully. What does that actually mean? Well, there's the concept of we're sending off this verification code, we're matching it to an email, and the user has to enter that verification code so that they will be allowed to reset their password. It's a relatively common form of two-factor authentication, if you like. So the interesting implication here is we're just glossing over a whole lot of logic here that we may need to explore. So our basic rule that we're trying to elaborate here is that a verification code is required to reset the password. Let's take that up a bit. Now here we've got several examples. I'm just going to write them down here and we'll flesh them out as we think of them. The first example is the obvious one. Fabian enters the verification code that he just received. But, and we'll get to the given one then in a second, but there could be other examples as well, counter examples. What else could happen? What happens if Fabian gets it wrong? He enters an invalid verification code, one that's not matched to his email, for example. Or what if he enters the verification code twice? So he's already tried to use that, or someone else tries to use it. Someone finds his email and hacks it and tries to reset his password. So to get around that, we'll need to check for making sure that he can only use it once. So we could have Fabian or some other user. How can we say that? If we just make it simple and have it, Fabian enters an expired verification code. So the code is good for his email address, but it's already been used. So all of this one line actually expands into at least 3 different examples. So let's flesh out what those examples would look like. So given Fabian has requested a verification code to reset his password, we might be able to just say, given Fabian has requested to reset his password, would be a valid option as well. But we might want to flesh it out. And then what actually happens next? When he enters the correct verification code, or maybe we want to say provides, make it a little bit less tied to the user interface, then he should be invited to reset his password. So that is basically, I've basically written these two lines. Given the context, he's been sent a verification code, so when he provides the correct one, he gets to reset his password. And then our counter example, I'm going to start off with the same step, but when he provides an incorrect verification code, then he should, whatever we decide will go wrong, be told that the code is invalid. And a logical thing would be to say he should be invited to request a new code verification code, for example. I'm just making up these rules, but you get the idea. And our third example, he doesn't request an invalid one, he provides an expired verification code. Now this will be, we'll probably say it's invalid, or we could actually explicitly say it's expired. That would be up to us. And if it's expired, I mean, I'm assuming that he'll be invited to send another one. So we've wrapped up these two lines actually hide away three different business rules, or one business rule with three variations that are really valuable to explore. So that's what you can see, just getting the gist of what we're doing here. When we have these long scenarios that try to do heaps of things, we're actually hiding away business rules and business logic that we really want to explore if we want to get good coverage. So the next rule I want to do is this final bit. This guy. User fills his password. Let's see what that looks like. The user fills in the password details. If it's blank and then the confirm password has something, then password field cannot be blank, confirm password cannot be blank, password one, the passwords don't match. For some reason it's an invalid password, and then if it's a valid password it gets reset successfully. And so there's a lot going on here. It's actually, I think the idea is we're looping over these. We would need to use some sort of soft assertion technique for this to work. We can do it this way, but it's not the usual way we do things, but we could. If we did choose to use this soft assertion approach, typically we would not have this successful case. We'd have the successful case separately. Let's see what that might look like. So imagine, let's define a rule. So our rule would be when resetting the password, normal password validation criteria should be met. So let's have a look at a couple of ways we could do this. First one, let's see what happens if we try to do this soft assertion approach. So example, Fabian enters an incorrect password or unacceptable password of some kind. Not the best wording in the world, but it will do for now. So when Fabian is resetting his password, now this step is going to go through all of that process. We're not assuming these other scenarios have been executed. We are not running step by step and following through. These scenarios are independent. So here we would be setting up the application context so we can jump straight in. Fabian has requested a password, he's given the right verification code, all of that's set up. He goes straight to the resetting password. these scenarios should be independent. That's a core principle of BDD scenarios, otherwise it gets very clunky. So we've got Fabian is resetting his password. How can we do this? When then the normal password rules should apply as illustrated here, and we might use a table a little bit like this one. Let's see what this would look like. I'd probably just not say the word blank. Could do, but it's a bit confusing. I'd just have it blank. And password 1, password 2, sure. Invalid password. Why is it invalid? What's invalid about that? I'd probably be a little bit more explicit. So we might say something like, imagine we had some sort of complexity rules or rules about what we need to put in a password. So we might have a rule that describes that. Password to simple must contain whatever. And we could have several examples of that as well, if we wanted to. Or just one to make sure that the algorithm is working. That would depend on the nature of the password validation, but that's the general idea. Our different edge cases, we've got our mandatory fields and also the password strength that we need to consider. That'd be one way of doing it. Another way would be with a scenario outline. So a scenario outline, we would have something like this. Fabian enters an unacceptable word. Again, that's just so we can distinguish between the two scenario names. Now, given Fabian is resetting his password, this will be a more conventional given one then. Given Fabian is, this table is going to go down the bottom in our examples. So when Fabian enters the following values, and here we're going to say what values we want to enter, maybe a little table. We could put this in line as well. Doesn't have to be a table. Confirm password, and then I'm going to put the variables. Then what should happen? Then the password should not be accepted, and Fabian should be informed that, let's put maybe the message here. Make the message uppercase so it matches. So IntelliJ will take a little while to update the syntax, but that is essentially our two possible approaches. One where we use some kind of soft assertion, where inside here we're checking the result for each one, but at the end we do an assertion. I do some other videos on how to do that. Or we could do a scenario outline approach, more conventional. So given Fabian is resetting his password, when he enters whatever one of these values, then the password should not be accepted. So that is the essence of that business rule. There was one that I glossed over, one last step, which was, if I recall correctly, the password should be set, or something along those lines. The last line was, then the password should be reset, something like that. How does that work? Well, the interesting question is, what does that actually mean? What does it mean that the password is reset? And this would typically be a user journey, what we call a user journey scenario, where we describe the end-to-end flow in a more succinct way. So we might describe a rule. Once the password is reset, the user can log in with their new password. I mean, it's fairly obvious, but that would cover what we're trying to do. And now, let's say, given Fabian, well, we could just start here again. So given as Fabian has got to that point and he has reset his password to a new value. Not sure whether that's necessary, the new value bit, but oops, I forgot the example. Example, Fabian successfully resets his password. And he has reset his password to a new value when he attempts to log in with his new password, and the login should be successful. Now that is the rule that flows on from these. Now remember, these are not sequential. They can be run in any order. If one breaks, we should know the status of the other ones. So we're not relying on this scenario to pass for all of the others to work. They are independent of each other. That's why we can start at this point, any point. We can say Fabian is resetting his password. If we wanted to do more of a user journey style approach, we could do something like this. Fabian forgets his password and resets it. Then we could possibly reuse some of these steps. We've got our given, given Fabian has asked to reset his password, and then what does he do along these next steps? He's going to have to enter his email and validate the verification. When he verifies, provides, we could say receive, well actually, you know what, let's make it clear. And he has received his verification code. This may not actually do anything, but it's good documentation. When he provides the verification code and he resets his password to a new value, then he should be able to log in with the new password. Now, what we're doing here is this is what we call a journey scenario. Very important to distinguish between the business rules that we've been talking about and a journey scenario, which would be a little bit more of an end-to-end flow. So this is, I'm trying to get a comment here, journey scenario where we actually do the end-to-end journey to make sure that it all hangs together. Now logically, we've stepped through this process. This is not necessary. We don't need to do all this. We already know it works. But if we wanted to verify all this through the UI and have some screenshots and have some evidence, then this would be a good way of doing it. But you see our original scenario. Notice we did all this random logic as we went through. We checked the valid email or non-valid email. We did not worry about business rules for this verification code, so we skimmed over that bit, but then we went and dived into the details of the password, and we didn't verify what the actual outcome of the password was. We've actually replaced, in essence, all of this by this scenario, this end-to-end scenario. Then we've drilled into the rules with our other scenarios where we get much more confidence that we have covered all the edge cases and all the variations at a business level that we need to. So that in essence is how we go from a single scenario that really does try to do quite a lot and verifies quite a lot of things to a set of business readable rules and examples that document the requirements in a much more thorough and much more reliable manner. So hopefully that's helpful and you can apply it to your own projects and to your own scenarios.